Hello, friend. I am Neil Tyson, and tonight I will be your guide on a journey into the quietest corner of the cosmos, a place of serene and graceful stillness. Settle in, let the weight of the day drift away, and allow your mind to float among the stars. We are going to explore a very special family of elements, the noble gases. They reside on the far right edge of the periodic table, like a row of silent, contemplative monks, complete in and of themselves. They are called noble not because of any crown or title, but because of their profound self-sufficiency. Their outer shell of electrons is perfectly full, a complete set, leaving them with little desire to react or bond with the other, more turbulent elements. They are at peace. They are whole. In their quiet inertness, they hold a mirror to the tranquility we seek. They remind us that there is a deep and abiding beauty in stillness, in simply being. Tonight, we will drift through their stories, one by one, from the lightest to the heaviest, from the birth of the universe to the frontiers of human discovery. So take a slow, deep breath. Let it fill you with the calm of deep space. And now, let it go. Our journey begins with the very first breath of the cosmos, a whisper of an element that fills the stars themselves. Our journey begins with helium. Helium is the first of our noble family, and perhaps the most cosmic. Its story does not begin on Earth, but in the fiery heart of a star. In fact, for a time, we believed it existed only there. Imagine the year 1868. The French astronomer Pierre Janssen travels to India to observe a total solar eclipse. As the moon perfectly covers the sun's brilliant face, the star's atmosphere, the chromosphere, becomes visible as a thin reddish ring. Janssen uses a new instrument, a spectroscope, to break this faint light down into its constituent colors, a rainbow barcode of the elements present. He sees the familiar lines for hydrogen, but he also sees something else. A bright yellow line that corresponds to no known element on our world. It was a signature from a stranger. That very same year, the English astronomer Norman Lockyer, observing the sun from the clear skies of London, also saw this mysterious yellow line. He concluded, with astonishing insight, that he was looking at an element unknown to Earth, an element of the sun. He and his colleague Edward Frankland gave it a name befitting its celestial origin. They called it helium, after Helios, the Greek god of the sun. For years, helium was a celestial myth, a sun element with no terrestrial home. It was a beautiful idea that the stars could be made of something different from our world, something ethereal. But helium was not just in the sun, it was everywhere. Our first fact is a grand one. Helium is the second most abundant element in the entire universe. Only hydrogen, the simplest element of all, is more common. Together, they are the foundational pillars of the cosmos. Nearly a quarter of all the ordinary matter in the universe, by mass, is helium. Every star you see in the night sky is a colossal factory, fusing hydrogen into helium, releasing the light and energy that travels across unimaginable distances to reach your eye. The starlight that paints our night is the afterglow of helium's creation. Its story begins even before the first stars. Scientists believe that most of the universe's helium was formed in the first few minutes after the Big Bang. In that initial, unimaginably hot and dense crucible, protons and neutrons fused together to form the first simple atomic nuclei. It was the first act of cosmic creation, and helium was its first masterpiece, after hydrogen. It is, in a very real sense, the first breath of our universe, an elemental echo of the very beginning of time. So, if helium is so incredibly common in the cosmos, why was it so hard to find on Earth? This brings us to our second fact about this remarkable gas. Helium is so light, it is a cosmic escape artist. An atom of helium is the second lightest of all atoms, composed of just 2 protons and 2 neutrons in its nucleus, orbited by 2 perfectly content electrons. On a world with gravity as gentle as ours, a helium atom, if freed into the atmosphere, can eventually gain enough speed from the jostling of other molecules to simply float away. It can reach escape velocity and drift off into the blackness of space, a tiny balloon released into the infinity of the cosmos. This is why our atmosphere contains only about 5 parts per million of helium. It's a cosmic treasure that our planet has a hard time holding on to. The vast majority of the helium that Earth was born with has long since vanished into space. It wasn't until 1895 that helium was finally proven to exist on our planet. The Scottish chemist Sir William Ramsay, a masterful and patient scientist who we will meet again in our journey, was studying a mineral called clevite. When he treated the mineral with acid, it released a gas. Ramsay suspected it was nitrogen. He collected the gas and, like Johnson and Lockyer before him, he used a spectroscope to examine its light. He looked for the familiar lines of nitrogen, but they weren't there. Instead, he saw a brilliant, solitary yellow line, a perfect match for the mysterious line observed in the Sun's corona nearly 3 decades earlier. The celestial element was here, locked away in the rocks beneath our feet. The sun god, Helios, had a terrestrial home after all. This is our third peaceful fact. The helium on Earth does not come from the sun, nor is it a remnant from the planet's formation. It is continuously, but very slowly, being created within the Earth's crust. It is the product of the slow, patient decay of heavy radioactive elements like uranium and thorium. Over millions upon millions of years, these heavy elements shed particles, one of which is something called an alpha particle. And an alpha particle is, in fact, simply the nucleus of a helium atom. When this nucleus captures 2 stray electrons, a new atom of helium is born, a tiny ghost released from ancient stone. It then gets trapped in pockets of natural gas from which we collect it. Every bit of helium you have ever encountered, in a balloon or in a laboratory, is the result of this ancient, silent geological process. It is a whisper from the deep earth, an echo of geologic time. This terrestrial helium has some of the most extraordinary properties of any substance in the universe. Let's consider its relationship with cold. Helium has the lowest boiling point of any element. To turn helium gas into a liquid, you must cool it to an astonishingly low temperature, -269 degrees Celsius, or just about 4 degrees above absolute zero, the theoretical point where all atomic motion ceases. This is our fourth fact, a fact that speaks of a cold so profound it is difficult to imagine. It is the cold of interstellar space, the quiet between the stars. And this property makes liquid helium one of the most important tools in modern science and medicine. It is the ultimate coolant. Imagine the quiet, rhythmic hum of an MRI machine in a hospital. Inside that large white machine is a powerful superconducting magnet, and to work, that magnet must be kept incredibly cold. It is bathed in a bath of liquid helium. The silent power of helium allows doctors to see inside the human body with incredible clarity, without any harm. The deep cold of helium provides a window into our own biology, a testament to how this cosmic element helps us understand ourselves. This cryogenic power is also essential for fundamental physics. At the Large Hadron Collider in Switzerland, the world's largest and most powerful particle accelerator, nearly 100 tons of liquid helium are used to cool the thousands of superconducting magnets that guide particles at nearly the speed of light. Helium's profound cold allows us to probe the very building blocks of the universe from which it was born. But the story of helium and cold gets even stranger and even more wonderful. If you take liquid helium and cool it even further, just a couple of degrees below what is known as the lambda point, about -271 degrees Celsius, it transforms into a completely new state of matter. This is our fifth fact. Helium becomes a superfluid. It is called helium-2. In this state, it loses all viscosity. It becomes, in essence, a frictionless liquid. A superfluid can do things that seem to defy common sense. It can flow up and over the sides of a container as if pulled by an invisible siphon. It can seep through cracks so small that not even the gaseous form of helium could pass through. It conducts heat perfectly without any resistance at all. There are no bubbles in boiling superfluid. It simply evaporates silently from the surface. It is a quantum phenomenon made visible, a glimpse into a strange and beautiful world where the rules of physics are bent into new and elegant shapes. It is the universe showing us that even in the deepest cold, there is a kind of perfect, silent, flowing motion. Let's float back up from the world of absolute zero to something lighter, literally. Helium is, of course, famously lighter than air. Only hydrogen is less dense. But unlike hydrogen, helium has a crucial, noble property. It is completely non-flammable. It will not burn or react with anything. This brings us to our sixth fact. This inherent safety and lightness made helium the perfect choice for lifting things into the sky. While we often think of party balloons, its most significant use is in large airships and high-altitude balloons. Imagine a weather balloon, a large, pale sphere being released into the dawn sky. It rises silently, without effort. It is lifted by the gentle, steady push of countless helium atoms, each one eager to climb higher. The balloon ascends through the clouds, into the thin, cold air of the stratosphere, carrying its delicate instruments to measure our atmosphere, to help us understand our world's weather and climate. It is a quiet, peaceful messenger sent to the edge of space on a breath of cosmic air. There is no engine, no roar, just a slow, graceful climb, a perfect picture of tranquility. This non-reactive nature, its noble stability, is also used to protect things here on the ground. Our seventh fact is about helium's role as a guardian. In the world of advanced welding, especially with materials like aluminum or titanium, the tiniest amount of oxygen from the air can contaminate and weaken the weld. To prevent this, a continuous stream of an inert gas is used to blow away the surrounding air, creating a temporary, protective atmosphere around the molten metal. Helium is often chosen for this task. It forms an invisible, impenetrable shield, allowing for a pure, strong, and perfect bond to be created. It is a quiet guardian, ensuring strength and integrity through its own peaceful refusal to interfere. Before we leave this first, light-hearted member of our noble family, let's explore one more of its gentle uses. In the world of deep-sea diving, the pressure of the water far below the surface can cause problems for divers breathing normal air. Under high pressure, the nitrogen in the air can dissolve into the bloodstream and cause a disorienting condition known as nitrogen narcosis. To go deeper, safely, divers often breathe a special mixture of gases. Our eighth fact is that helium is a key ingredient in these mixtures, most notably one called heliox, a simple blend of helium and oxygen. Because helium is so much lighter and less soluble in blood than nitrogen, it allows divers to descend to incredible depths and still think clearly. It allows them to work safely in the deep, dark, quiet world of the ocean floor. From the highest reaches of the atmosphere to the crushing depths of the sea, helium provides a gentle, steadying presence. It is the sun element, the first breath of the cosmos, the silent lifter, the perfect coolant, the invisible shield, and the deep-sea explorer's steady companion. It is a reminder that the simplest things in the universe are often the most profound. As you breathe in and out, imagine that lightness, that cosmic serenity. Let it fill you, and as you exhale, feel yourself becoming just a little bit lighter, drifting peacefully into a state of deep and restful calm. Now, let us drift from the cold, vast emptiness of space and the silent ascent of a weather balloon to a different scene. Imagine a quiet city street on a misty evening. The rain has just stopped, and the pavement glistens, reflecting the soft, colorful lights of the city. There is one light in particular that is warm and inviting, a steady, humming glow that seems to paint the air itself. It is a soft, reddish-orange light, shaping a word or a beautiful, simple design. This is the light of our second noble gas. This is the glow of neon. Our journey to neon begins back in the same London laboratory of Sir William Ramsay and his assistant Morris Travers. It is 1898, just a few years after they had successfully isolated helium and argon from the air.
They were convinced that the periodic table predicted the existence of other, undiscovered noble gases hiding in our atmosphere. They embarked on a painstaking process of liquefying large amounts of air and then carefully, slowly boiling it off, one fraction at a time. They collected the first, most volatile gas to boil off. It was helium. They collected the large fraction of nitrogen and the slightly less large fraction of oxygen. They isolated the sluggish, heavy vapor that was argon. But they suspected there was something else hiding between the helium and the argon. So they meticulously refined their process, collecting a small sample of gas that was heavier than helium but lighter than argon. They placed this tiny purified sample into a vacuum tube, an electrical device called a Geissler tube, and passed a high-voltage current through it. And then it happened. In Travers' own words, the blaze of crimson light from the tube told its own story and was a sight to dwell upon and never to forget. It was a light unlike any they had ever produced before, a brilliant, fiery, and completely new color. This is our ninth fact, a fact of pure discovery and wonder. When subjected to an electric current, neon gas produces a magnificent, unmistakable reddish-orange glow. Ramsay's young son, who was in the laboratory, suggested a name for this brilliant stranger. He suggested novum, the Latin for new. But Ramsay preferred the Greek equivalent. He called it neon, from the Greek word neos, meaning the new one. It was a perfect name for a substance that had introduced a completely new color to the palette of science.
That crimson blaze was the signature of a new element, a new member of the noble family, hiding in plain sight in every breath of air we take. That brilliant glow is the heart of neon's story, and it is a story about the secret life of atoms. An atom of neon has 10 electrons, arranged in two perfectly stable, complete shells. It is content. But when you pass a high-voltage current through the low-pressure gas in a tube, the energy excites these electrons. It kicks them temporarily into a higher, more energetic orbit. But this state is unstable. The electron cannot stay there. Almost instantly, it falls back to its original, comfortable ground state. And as it falls, it must release the extra energy it absorbed. It releases this energy in the form of a tiny particle of light, a photon. And our 10th fact is this. The specific color of that light, that precise shade of fiery reddish-orange, is determined by the exact amount of energy the electron releases. It is a fundamental property of neon. Every neon atom in the universe, when it sings its electric song, sings in this exact same color. It is a cosmic constant, a universal truth written in light, a truth that now illuminates our cities and our art. For a long time, this beautiful glow was a laboratory curiosity. It wasn't until the French engineer Georges Claude figured out how to produce industrial quantities of neon in the early 1900s that its future became clear. He also developed a reliable glass tube and electrode system to contain the gas and make it glow for thousands of hours. Our 11th fact is that Georges Claude unveiled the world's first neon sign to the public at the Paris Motor Show in 1910. Two enormous, 12-meter-long glass tubes filled with neon glowed with that brilliant crimson light. The public was mesmerized. It was like capturing fire in a glass bottle. Soon after, in 1923, he sold 2 signs to a Packard car dealership in Los Angeles, and the era of the neon sign began. The warm, steady glow of neon became synonymous with modernity, with glamour, with the promise of the city at night. It became the lifeblood of urban landscapes, from the dazzling spectacle of Times Square to the lonely sign of a roadside diner on a deserted highway. You may be wondering, if neon itself only glows reddish-orange, where do all the other colors of so-called neon signs come from? This leads us to our 12th and quite colorful fact. The beautiful variety of colors you see in glowing signs is an artful combination of noble gases and clever chemistry. True, pure neon is always that signature red-orange. But if you want a blue light, for instance, the tube is typically filled not with neon, but with our other noble friend, argon.
Argon on its own gives a faint, pale lavender glow. But if you add a tiny bead of mercury to the argon-filled tube, the electricity vaporizes the mercury, and its atoms emit a brilliant, strong blue light. For a yellow sign, a blue-glowing argon-mercury tube is made with yellow-tinted glass. For green, the same blue light is passed through glass coated with a green-emitting phosphor. And for white, the phosphor coating is white. So, most of the neon signs you see are actually powered by the quiet glow of argon, dressed up in different colors. But that original, warm, pure red, that is and always will be the true and unmistakable voice of neon. Like helium, neon is far more abundant in the cosmos than it is here on Earth. Our 13th fact is a cosmic one. By mass, neon is the 5th most abundant element in the universe, after hydrogen, helium, oxygen, and carbon. It is forged in the hearts of massive stars in the later stages of their lives, and then scattered across the galaxy in supernova explosions. The nebulae, those beautiful glowing clouds of interstellar gas and dust, are often rich with neon, and when their light is analyzed, we can see its familiar signature. So, the same element that powers a simple open sign on a cafe door also illuminates vast stellar nurseries hundreds of thousands of light years away. Yet, here on Earth, it is exceptionally rare. The air around us, the air you are breathing now, is only about 18 parts per million neon. This is our 14th fact. Why is it so rare? For the same reason as helium. Neon is relatively light and it is completely inert. During the formation of our planet, when the Earth was a hot, molten ball, the neon, which refused to bind with any of the rocks or minerals, simply floated away. It escaped the pull of Earth's gravity and was lost to space forever. The neon we have today is all that was left, a tiny, precious remnant of the cosmic clouds from which our solar system was born. This rarity, combined with the energy-intensive process of separating it from liquid air, makes neon a surprisingly precious substance. Despite its fame in lighting, neon has other, quieter uses. Its extreme cold properties are second only to helium.
Liquid neon can be used as a cryogen, a refrigerant for freezing things to very low temperatures. It doesn't reach the extreme cold of liquid helium, but it has over 40 times the refrigerating capacity, making it more efficient for certain applications. This is our 15th fact. But perhaps its most precise and unsung role is in the world of lasers. You may have heard of a helium neon laser, or He-Ni laser. This is a very common type of gas laser, known for its stability and its pure red beam. Our 16th fact is that in these lasers, it is the neon atoms that actually produce the laser light. The helium atoms are there to help. The electrical energy in the laser tube excites the helium atoms, and they, in turn, transfer that energy very efficiently to the neon atoms, bumping them into the precise energetic state needed to begin the laser process. The helium is the quiet assistant, and the neon is the star of the show, emitting that perfectly coherent, pencil-thin beam of pure red light that is used in everything from barcode scanners at the grocery store to scientific instruments for precise alignment. Like all the members of its family so far, neon is profoundly stable. It has a full outer shell of electrons and shows no interest in chemical reactions. To date, no stable, neutral compounds of neon have ever been created. This is our 17th and perhaps most defining fact about this element. It is content to be alone. It floats through the cosmos as single, unattached atoms. It fills a glass tube and, when asked to, puts on a brilliant show of light. But it does not connect. It does not bind. It remains itself, pure and aloof. Its glow is not the hot, chaotic light of a fire, which is a chemical reaction, but the cool, orderly light of physics. It is the light of a serene atom, sharing its inner energy with the world for a moment before returning to a state of perfect, noble peace. As you settle deeper into relaxation, imagine that gentle, warm, neon glow. Let it be a steady, calming presence in your mind. It asks nothing of you. It simply is.
A soft, reddish light at the edge of your awareness, a symbol of quiet contentment, of the beauty of being complete, just as you are right here, right now. Leaving the warm, dreamy glow of the city lights behind, our journey now takes us into the very air that surrounds us, into an element that is so common yet so hidden, it was named the Lazy One. It is an invisible shield, a silent guardian that fills our atmosphere and protects some of our most delicate and precious things. We are turning our attention now to argon. If helium is the cosmic breath and neon is the city's dream, argon is the quiet, familiar presence of home. Our 18th fact is a startling one. Argon is the third most abundant gas in the Earth's atmosphere. The air you are breathing at this very moment is roughly 78% nitrogen and 21% oxygen. You might assume the remaining 1% is composed of many different trace gases, but the vast majority of it, about 0.93%, is pure argon. This means that with every breath you take, you draw more argon into your lungs than you do carbon dioxide. It is all around us, all the time, an invisible ocean in which we live. And yet, for most of human history, we were completely unaware of its existence. It is the perfect noble gas, present everywhere but participating in nothing. Its discovery story is one of incredible scientific precision and a nagging puzzle. It begins in the late 19th century with the English physicist Lord Rayleigh. He was engaged in the painstaking work of determining the precise densities of various gases. He found that the density of nitrogen, when produced from a chemical reaction, was always consistent. But when he extracted nitrogen from the air by removing the oxygen, carbon dioxide, and water, the result was always slightly but measurably different. The nitrogen from the air was always about 0.5% denser than the nitrogen from chemical sources. This tiny discrepancy haunted him. In science, such a small, persistent difference is not an error. It is a clue, a whisper of a hidden truth. Unable to solve the puzzle himself, he published his findings, a call for help to the scientific community. The call was answered by the same Scottish chemist we have met before, the brilliant Sir William Ramsay. Together, they hypothesized that the air-derived nitrogen was not pure. It must contain a small amount of another, unknown gas that was heavier and denser than nitrogen. To prove it, they passed atmospheric nitrogen over hot magnesium metal, which reacts with nitrogen to form a solid, magnesium nitride. But a small bubble of gas always remained, a gas that refused to react with anything. They had found it. They had isolated the lazy, unreactive component of the air. This is our 19th fact. In 1894, Rayleigh and Ramsay announced the discovery of a new element.
In honor of its defining characteristic, its complete lack of reactivity, they named it argon, from the Greek word argos, which means inactive or lazy. It was the perfect name for this quiet, solitary element that had hidden so effectively in the air around us. So, where did all of this atmospheric argon come from? Unlike helium and neon, which largely escaped the early Earth, argon had a way of staying put, and its presence has been slowly growing over geologic time. Our 20th fact reveals its origin. The vast majority of argon on Earth is argon-40, which is produced by the slow radioactive decay of potassium-40, an isotope of potassium found in the Earth's crust. Over billions of years, as potassium-40 atoms within rocks and minerals have decayed, they have released this argon gas, which then seeps out and makes its way into the atmosphere. The argon in the air is, therefore, like helium, a geological breath. It is a slow exhalation from the planet itself, an accumulation of eons of silent, patient, radioactive transformation. When you breathe in, you are breathing in the ancient history of our planet's rocks. The primary quality of argon, its inertness, has made it one of the most useful and versatile of the noble gases. Its most common use is as a protective shielding gas, a role we saw helium play, but which argon performs with exceptional efficiency, due to its greater density and lower cost. Our 21st fact concerns the world of welding.
When joining metals at high temperatures, argon is often pumped over the joint. Being denser than air, it settles over the area and pushes the reactive oxygen away, preventing oxidation and creating a cleaner, stronger weld. It creates a temporary, localized, perfectly pure atmosphere where the delicate work can be done, an invisible bubble of inert safety. This same protective quality gave us a brighter, longer-lasting world. Think of the classic incandescent light bulb with its delicate, glowing filament. Our 22nd fact is that these bulbs are not filled with a vacuum as one might think. They are filled with an inert gas, and that gas is almost always argon. If the hot tungsten filament were exposed to even a tiny amount of oxygen, it would burn out in an instant. Early bulbs used a vacuum, but the tungsten would slowly evaporate and deposit on the glass, blackening it. By filling the bulb with argon, the gas atoms provide a sort of pressure, a cushion that surrounds the filament and makes it much harder for the tungsten atoms to evaporate. The argon gas doesn't interact with the filament, it simply gets in the way of its decay. It is a silent, passive protector that allows the filament to glow brighter and last for thousands of hours longer, filling our homes with warm, steady light. Argon's protective nature extends beyond industry and into the realm of history and culture. Some of the world's most precious documents, artifacts that carry the weight of human history, are preserved for future generations under the watchful, placid gaze of argon. Our 23rd fact is a profound one. The original copies of the United States Declaration of Independence and the Constitution are stored in specially designed sealed cases filled with humidified argon gas. The previous cases used helium, but argon, being heavier, is less likely to escape over time. The argon atmosphere protects the delicate ink and brittle parchment from the slow, relentless decay caused by oxygen. It halts the process of aging, cocooning these foundational texts in a timeless, chemically silent environment. The gas that was once called lazy now has the vital job of preserving liberty's words, a quiet, invisible guardian of history. The protective quality of argon has also found its way into our homes in a much more common, yet equally invisible way. If you have modern, energy-efficient double-paned or triple-paned windows, you may have a layer of argon right in your home. Our 24th fact is that the space between the panes of glass in these insulated windows is often filled with argon gas. Why? Because argon is a much poorer conductor of heat than regular air. This colorless, odorless gas acts as a thermal barrier, a transparent blanket. In the winter, it helps keep the warm air inside, and in the summer, it helps keep the hot air out. It makes our homes more comfortable and more energy efficient, all while remaining completely unseen, a silent and diligent worker in the cause of comfort and conservation. Even the world of fine food and drink benefits from argon's noble stillness. Oxygen is the enemy of an open bottle of wine, causing it to oxidize and quickly lose its complex flavors. Our 25th fact is that wine preservation systems often use small canisters of pure argon.
By spraying a small amount of the heavy gas into a partially empty bottle before recorking it, the argon, being denser than air, forms a perfect protective layer on top of the wine's surface. It pushes the oxygen away, preserving the wine's taste and aroma for days or even weeks. It is the lazy gas, once again, performing a delicate and important job, the preservation of pleasure, the simple act of making a good thing last. From the very air we breathe to the light bulbs that illuminate our rooms, from the windows that keep us warm to the historical vaults that keep our heritage safe, argon is the unseen, unsung hero of the noble gases. It is a reminder that great strength can be found in quiet stillness, that protection can be offered through simple presence, and that even the laziest among us can have a profound and vital purpose. As you continue to relax, feel the quiet, protective presence of this gas. Let it be a metaphor for the safety and peace that surrounds you now. You are in a safe space, shielded from the complexities of the world, free to simply be, to rest, to drift into a deep and profound sleep. Let us now venture deeper into the quietest regions of the periodic table, leaving the abundant, familiar presence of argon behind.
Our search continues alongside those patient pioneers, Ramsay and Travers, for the even more elusive members of this noble family. They knew the patterns of the periodic table predicted more gases, heavier and rarer still, hiding in the vast ocean of air. Their method was one of extreme patience. They would liquefy enormous volumes of air, and then, in a process of painstaking fractional distillation, they would allow the liquid to slowly warm, carefully collecting each gas as it boiled off. They collected the nitrogen, the argon, and after much effort, they had found neon. But in the residue left behind, in the very last, coldest drops of liquid air, they believed something else remained, a ghost, a whisper of an element. This is the story of Krypton, the hidden one. After separating out the argon, Ramsay and Travers were left with a small amount of a heavier, less volatile liquid. They purified it and once again placed a sample into a spectroscope's vacuum tube and passed an electric current through it. They had witnessed the crimson fire of neon, but this was something entirely different. The tube glowed with a pale, silvery light, a mix of brilliant green and orange-yellow lines that had never been seen before. They knew they had found another new element, one that had been concealed within the argon fraction all along. Our 26th fact is about its name. In honor of its elusive nature, they named it Krypton, from the ancient Greek word kryptos, meaning the hidden one. It was perfectly named, an element so shy it had taken all of their ingenuity to coax it out of its hiding place in the air. Krypton is extraordinarily rare. While we are surrounded by argon, Krypton is a mere trace. For every million particles in the atmosphere, only about one of them is an atom of Krypton. This is our 27th fact. It makes Krypton a precious and costly gas to produce, a treasure distilled drop by drop from a sea of liquid air. Like its lighter siblings, the Krypton present on Earth today is a remnant from the planet's formation, a tiny fraction that didn't escape into the void of space billions of years ago. The light that Krypton produces is perhaps its most defining feature. Unlike neon's singular fiery red, Krypton's glow is more complex, more ethereal. When excited by electricity, it emits light at several different wavelengths simultaneously, creating a powerful, brilliant white light. This quality brings us to our 28th fact. Krypton is a master of high-intensity lighting. Its brilliant sunlight spectrum makes it ideal for situations where a bright, clear, and true white light is needed. Imagine for a moment a dark room, perfectly still. You are about to capture a memory, a moment in time. There is a gentle click, and for a fraction of a second, the entire room is filled with an instantaneous, shadowless, brilliant white light. Then, just as quickly, it is gone, leaving a soft, fading impression on your eyes. That sudden, clean burst of light is the magic of a Krypton-filled flashbulb. Our 29th fact is that Krypton's ability to produce this intense white light very quickly and efficiently made it a key component in flash photography for many years, illuminating countless moments of joy and history before returning the world to its peaceful, ambient state. Now, let us imagine another scene. You are on an airplane, descending through a thick blanket of fog on a dark and quiet night. Below, through the swirling gray, you cannot see the ground, only a formless expanse. There is a sense of anticipation, of trust. And then you see it. Two parallel lines of piercingly bright lights cutting through the thickest fog with absolute clarity.
They are not warm or soft, but sharp, white, and unwavering. They form a path of pure light, a welcome beacon guiding you safely home. This is perhaps Krypton's most vital and reassuring role. Our 30th fact is that high-intensity airport runway and approach lights are often filled with Krypton. Its powerful white light has the specific characteristics needed to penetrate fog, rain, and snow, ensuring that pilots can find their way in even the most challenging conditions. It is the hidden gas, revealing the path to safety. It is a quiet, steady guide in the storm. This proficiency with light has found its way into our homes as well. Krypton is used to fill certain types of energy-efficient fluorescent lamps, helping them to start more easily and operate more efficiently. It is also used in some high-performance halogen light bulbs.
Our 31st fact is that by adding krypton to the gas mixture inside a halogen bulb, the filament can burn hotter and brighter without burning out quickly. The heavy krypton atoms act like a dense crowd around the filament, making it more difficult for the tungsten atoms to evaporate, much like argon does, but even more effectively. This allows for a bulb that is smaller, yet more intense, producing a whiter, more vibrant light. It is a quiet upgrade, a hidden improvement to the light that fills our daily lives. For a period of time, krypton's light was not just for illumination. It was the fundamental standard for measuring our world. In the quest for an unchanging, universal definition of length, scientists turned away from physical objects, like a metal bar, and toward the fundamental constants of the universe. Our 32nd fact is a beautiful piece of scientific history. From 1960 to 1983, the official international definition of the meter was based on the light of krypton. Specifically, 1 meter was defined as exactly 1,650,763.73 wavelengths of the orange-red spectral line emitted by an atom of the isotope krypton-86. For 23 years, this hidden element, this faint trace in our atmosphere, served as the cosmic ruler for all of humanity. It was an acknowledgement that the most reliable truths are not forged by human hands, but are written in the very nature of the atoms themselves, in the light they so steadily emit. Of course, for many, the name Krypton brings to mind something else entirely, a fictional world of superheroes and strange glowing green crystals. Our 33rd fact gently touches on this story. The element krypton, the noble gas, is very real, stable, and completely gentle. It has no connection to the mythical planet Krypton, the home of Superman, nor to the dangerous kryptonite of lore. The creators of that story simply chose a name that sounded scientific and mysterious, a name that perfectly evoked a sense of an alien, hidden world. And they chose well. The name itself, the Hidden One, carries a natural poetry, a hint of secrets and otherworldly origins. But the reality of Krypton is one of quiet utility and serene stability. It is a gentle, earthly element content to provide its brilliant, guiding light and then recede back into its quiet, hidden state. As we let the idea of that brilliant white light soften in our minds, let us drift even deeper into the last, coldest remnants of liquid air. Ramsay and Travers, having found Argon, the lazy one, and Krypton, the hidden one, were still not satisfied. The elegant symmetry of the periodic table suggested that another, even heavier and rarer gas must exist. They continued their relentless work of distillation, processing enormous quantities of air, searching for the final, heaviest fraction. And in the very last residue, after the kryptonite boiled away, they found what they were looking for. When they placed this final, precious sample into their spectroscope, they saw a new spectrum, a beautiful and complex pattern of blue and green lines against a lavender background. They had found the last of the stable noble gases to be discovered in the air. Our 34th fact is this. Because this element was so completely new and unexpected, a true foreigner in the familiar atmosphere, they named it Xenon, from the Greek word xenos, which means stranger or foreign. It was the stranger gas, the final atmospheric prize. Xenon is the rarest of the rare. It is an element of profound scarcity. Our 35th fact puts this into perspective. For every 10 million atoms in the atmosphere, fewer than one is a xenon atom. To isolate even a small amount of xenon requires processing immense volumes of air, making it one of the most precious of all the elements that are not radioactive. Its atoms are heavy and slow-moving, and so, unlike helium and neon, xenon had no trouble staying bound to the Earth by gravity during the planet's formation. Its rarity is not because it escaped, but simply because it was never abundant to begin with. It is a true cosmic whisper.
Like Krypton, Xenon's story is deeply intertwined with light. But the light of Xenon is different. It is more powerful, more intense, and it shines with a distinct, brilliant blue-white hue that feels cool and futuristic. Our 36th fact is that Xenon produces a light spectrum that is remarkably close to that of natural daylight. This has made it the gold standard for high-intensity discharge, or HID, lamps.
You have likely seen this light yourself. Think of the headlights on many modern cars. That sharp, intensely bright, blue-tinted light that cuts through the darkness with such authority, that is the light of xenon. A small glass capsule in the headlight is filled with xenon gas and metal salts. An electric arc passes through the xenon, exciting it to produce its signature powerful glow. These headlights can illuminate the road farther and wider than traditional halogen bulbs, another quiet gift from a noble gas, making the dark roads a little safer. This bright, daylight-like quality is also essential for another kind of illumination, the magic of the cinema. Our 37th fact is about the light that brings stories to life. The incredibly bright, steady light needed for large movie projectors in theaters almost always comes from a xenon arc lamp. Inside the projector, a powerful arc of electricity passes through a small pressurized quartz tube filled with xenon gas. The result is a torrent of brilliant white light, intense enough to be projected across a vast, dark room and create a clear, vibrant image on a massive screen. The next time you sit in a dark movie theater, watching a world unfold before you, remember that the very light painting those images on the screen, the light creating that shared dream, is the glow of the stranger gas, xenon, shining steadily in the heart of the projector. Xenon's light does not just illuminate our roads and our theaters, it is helping to carry us to the stars. One of the most futuristic and elegant forms of spacecraft propulsion is the ion thruster. It is a technology of quiet, relentless patience. Our 38th fact is that xenon is the preferred fuel for most modern ion drives. Inside the engine, xenon atoms are given an electric charge, turning them into ions. Then, a powerful electromagnetic field accelerates these ions and shoots them out of the back of the engine at incredibly high speeds, up to 90,000 miles per hour. The push from each individual ion is minuscule, about the same pressure you would feel from a single piece of paper resting in your hand. But in the frictionless vacuum of space, this tiny, continuous push, maintained over months and years, can accelerate a spacecraft to enormous speeds. It is the ultimate expression of gentle, persistent effort. Missions like NASA's Dawn spacecraft, which orbited the two largest objects in the asteroid belt, Vesta and Ceres, were made possible by the silent, steady, ethereal blue glow of a xenon-powered ion engine. It is the stranger gas, pushing us gently toward new worlds. Now, we come to a point in our journey where the story of the noble gases takes an unexpected turn. For decades, it was a fundamental truth of chemistry that the noble gases were completely inert. Their full electron shells meant they could not and would not form chemical bonds. They were aloof, perfect, and unreactive. But the stranger gas, xenon, would be the one to challenge this rule. In 1962, the chemist Neil Bartlett at the University of British Columbia was working with a highly reactive platinum compound. He observed it reacting with oxygen, and he realized that the energy required to pull an electron from an oxygen molecule was very similar to the energy required to pull one from a xenon atom. He wondered, could the same reaction work on the unreactive xenon? He tried the experiment. He mixed the deep red vapor of his platinum compound with the colorless, heavy xenon gas. And a chemical reaction occurred. A new orange-yellow solid was formed. Our 39th fact is a landmark in the history of chemistry. Neil Bartlett had created the first true chemical compound of a noble gas, xenon hexafluoroplatinate. The age of inertness was over. The noble gases were not completely aloof after all. Under the right circumstances, with a persuasive enough partner, even the noble stranger could be coaxed into a chemical bond. Since Bartlett's discovery, many other xenon compounds have been created, mostly with the highly reactive elements fluorine and oxygen. These compounds are powerful and unstable, but they prove that the nobility of these gases is not an absolute law, but rather a strong, deep-seated preference for solitude. Xenon, the heaviest of the stable noble gases, has electrons that are held more loosely by its large nucleus, making it the most likely to be tempted into a reaction. It revealed a hidden depth to this family, a secret potential for connection that no one had thought possible.
But xenon's surprises do not end there.
This heavy, strange gas has another remarkable property. It can act as an anesthetic. Our 40th fact is that when inhaled in a mixture with oxygen, xenon can induce a state of general anesthesia. It is actually a near-perfect anesthetic in many ways. It is powerful, it allows for rapid onset and recovery, and it appears to have very few side effects on the body's systems, like blood pressure or heart rate. Its high cost is the main reason it is not widely used, but for certain high-risk patients, the gentle, non-reactive nature of xenon anesthesia makes it an incredibly valuable medical tool. It is the stranger gas, capable of safely and gently guiding the human mind into a state of temporary, painless sleep. Beyond anesthesia, ongoing research is exploring xenon's potential to protect the brain. Our 41st fact is a hopeful one from the frontiers of medicine. Studies suggest that inhaling xenon may have neuroprotective qualities, meaning it could help shield the brain from damage after a traumatic injury or a loss of oxygen. The mechanisms are still being explored, but it appears the large, heavy xenon atoms can interfere with certain cellular receptors that are involved in the process of brain cell death. It is a remarkable thought that this incredibly rare inert gas, born in the hearts of dying stars, might one day be used to protect our most precious and complex organ. From the light of distant galaxies to the quiet, healing potential within our own minds, the stranger gas continues to reveal its secrets, proving that even in the quietest corners of the universe, there are profound and wonderful surprises waiting to be found. As you continue to drift, let the idea of this gentle, powerful gas fill your mind. A cool, blue-white light, a silent push through the cosmos, a surprising connection, a protective peace. Let the story of the stranger guide you into your own state of serene and deep repose. Our journey through this serene family of elements now takes us to a place of deep time, a place of profound and patient transformation. We have traveled from the lightness of the cosmos to the hidden corners of our own atmosphere. Now we must descend into the very rock and soil beneath our feet to find the next member of our noble family. This element is different from the others. It is not a primordial remnant of the solar system's birth, but rather an element that is continuously being born and just as continuously fading away. It is a whisper from the Earth's core, a fleeting echo of a much grander, ancient process. We have come to the story of radon. Unlike the other noble gases we have met, which were discovered through the meticulous distillation of air, radon was discovered through its connection to another, more famous element. At the turn of the 20th century, the world was captivated by the new science of radioactivity. Marie and Pierre Curie had discovered radium, an element that glowed with an eerie light and poured out a seemingly endless supply of energy. In the year 1900, the German physicist Friedrich Ernst Dorn was studying this remarkable substance. He noticed something strange. The area around a sample of radium became radioactive itself. He discovered that the radium was not just emitting rays, but it was also releasing a new invisible radioactive gas. This brings us to our 42nd fact. Radon was discovered as a gaseous emanation from the element radium. For a time, it was simply called radium emanation. It was later shown to be a new element, the heaviest of the naturally occurring noble gases, sitting just below xenon on the periodic table. The story of radon's origin is a story of lineage, of an elemental family tree. It is a tale that begins with one of the heaviest and most ancient elements in our solar system. This is our 41st fact. Radon is a natural product of the radioactive decay of uranium, which is found in trace amounts in most rocks and soils all over the world. The process is one of magnificent slowness, a cosmic clock ticking deep within the Earth. An atom of uranium-238, forged in a supernova billions of years before the Earth was born, will sit patiently within a piece of granite for eons. Its half-life is about 4.5 billion years, roughly the age of our planet. But eventually its time comes. Its nucleus becomes unstable and it decays, transforming into a new element and releasing a particle of energy. This new element is also unstable, and after some time, it too decays, beginning a long, slow cascade of transformations. This is called a decay chain. Uranium becomes thorium, which becomes protactinium, and so on, a series of steps down the periodic table. And one of the crucial links in this ancient chain is radium. And when an atom of radium decays, it gives birth to an atom of radon.
Imagine a single atom of radon being born, right now, deep within the soil of a quiet forest. For a moment, it is part of a solid mineral, but in its creation, it is set free. It is a noble gas, unbound by chemical ties. It is a tiny, invisible ghost released from its stone prison. This is our 44th fact. Because radon is a gas, and it is chemically inert, it can move. It can slip through tiny cracks in a rock, dissolve into groundwater, and slowly, gently percolate up toward the surface. Most of this radon simply seeps into the atmosphere, where it is diluted to harmless concentrations in the vastness of the open air. It is a constant, natural whisper from the deep earth, a process that has been happening for as long as our planet has existed. Radon is the heaviest gas known to exist under normal conditions. It is about 8 times denser than the air we breathe. If you could see it, and it is colorless, odorless, and tasteless, you would see it pool in low places, a heavy, invisible mist. But its most defining characteristic is its ephemeral nature. Our 45th fact is a testament to its fleeting existence. The most stable isotope of radon, radon-222, has a half-life of only about 3.8 days. This means that if you had a small collection of radon atoms, in less than 4 days, half of them would have vanished, their nuclei decaying and transforming into the next element in the chain, polonium. Radon is not a permanent resident of our world. It is a traveler, a momentary guest. It is born from radium and it fades into polonium. It is a fading echo of its ancient parent, uranium. Its existence is a gentle reminder that everything in the universe is in a state of flux, of slow and graceful change. In the early days of its discovery, the nature of radioactivity was still a deep mystery, and radon, or radium emanation, was seen as a source of wonder. Our 46th fact takes us back to this hopeful, if misguided, era. It was believed that the energy released by these new substances could have curative properties. For a brief time, radon was used in medicine. A process called radiotherapy involved sealing small glass tubes of radon gas, called seeds, and implanting them near unhealthy tissues. More popularly, health spas were established in places with naturally high levels of radon in the spring water. People would travel to breathe the radon-rich air in old mines or drink the radioactive water, believing it would alleviate their ailments. It was a time of great optimism, an attempt to harness a powerful, natural force before it was fully understood. We now know that this is not a safe practice, but it stands as a testament to our enduring desire to find healing in the natural world, even in its most mysterious corners. The very same properties that allow radon to move up through the earth can sometimes allow it to collect in enclosed spaces. As it seeps from the ground, it can enter our homes through small cracks in the foundation or gaps around pipes. Because it is a heavy gas, it tends to accumulate in the lowest levels, like basements. Our 47th fact is a quiet, practical one. In some regions, where the geology is rich in uranium, it is wise to be aware of the potential for radon to gather indoors. Simple tests can measure the levels, and if they are high, ventilation systems can be put in place to allow this natural gas to continue its journey back into the open air, where it belongs. This is not something to be feared, but simply understood. It is our modern way of listening to the whispers of the earth, of living in harmony with the natural, geologic processes that are happening all around us and beneath us all the time. Radon is a part of our planet's story. It is the ticking of a geologic clock, the slow breath of the rocks, a fleeting, noble presence that connects us to the deep and ancient history of the very ground on which we rest. Let the thought of this slow, patient transformation be a comfort. It is the rhythm of the cosmos, a cycle of creation and decay that is as peaceful as it is constant. And as you feel yourself settling,
you too can let go of the old and make way for the new in a state of perfect, restful peace. Our journey is now approaching the very edge of the map, the farthest shores of the known periodic table. We have met all the noble gases that can be found in nature, from the abundant helium to the fleeting echo of radon. But our story does not end here. The human spirit, in its endless quest to understand the universe, has not been content with just the elements that nature has provided. In great laboratories, with machines of incredible power and precision, we have learned to create new elements, elements that do not exist anywhere on Earth and perhaps anywhere in the cosmos.
We are entering the realm of the synthetic, the super heavy, the world of an element that exists for less than 1,000th of a second, but in its brief existence completes a profound chapter in the story of matter. We are journeying to meet the final and heaviest member of the noble family, Oganesson. The creation of an element like Oganesson is a feat of unimaginable force and delicacy. It is not found in a mine or distilled from the air. It is forged. This is our 48th fact. Superheavy elements are created in particle accelerators by colliding two lighter atoms together with such force that their nuclei fuse into one. The process is fantastically difficult. Imagine trying to hit a single tiny target with another equally tiny projectile, both moving at about 1/10 the speed of light. And you must hit it with just the right energy and orientation for the two to merge, rather than simply shattering. For every quadrillion projectiles you fire, you might get just one successful fusion. It is the ultimate needle in a haystack. The story of Oganesson, element 118, is the culmination of decades of work by dedicated scientists at laboratories around the world. Our 49th fact acknowledges its creators. Oganesson was first successfully synthesized in 2006 at the Joint Institute for Nuclear Research in Dubna, Russia, by a team of Russian and American scientists. They achieved this incredible feat by firing a beam of calcium-48 ions at a target made of californium-249. After months of running the experiment, sifting through mountains of data, they found the telltale signature of just a few atoms of a new, super-heavy element. Our 50th fact is in its name. The element is named Oganesson, with the symbol Og, in honor of the Russian-Armenian nuclear physicist Yuri Oganesson. This was only the second time in history that an element was named for a living person. The name honors his pioneering contributions to the discovery of the heaviest elements in the periodic table. The "on" suffix at the end of the name is a tradition, placing it firmly within the noble gas family, alongside neon, argon, krypton, xenon, and radon. It sits in the last spot of the 7th row of the periodic table, the heaviest element ever created, bringing a sense of beautiful completeness to that entire period. But here, at the extreme edge of existence, the rules begin to bend. Oganesson sits in the noble gas column, and so it should be a gas. But it is so heavy, its atoms packed with 118 protons and nearly 180 neutrons, that strange things begin to happen. Albert Einstein's theory of special relativity starts to play a significant role in the behavior of its electrons. The innermost electrons of such a massive atom are pulled in so tightly by the immense positive charge of the nucleus that they orbit at speeds approaching the speed of light. This has a cascading effect on the outer electrons, the very electrons that define an element's chemistry. This leads us to our 51st and truly mind-bending fact. Due to these relativistic effects, scientists predict that Oganesson is probably not a gas at all. It is expected to be a solid at room temperature, a noble solid. The forces between its atoms are predicted to be strong enough to lock them into a solid state, something unheard of for any other member of its family. It is a noble element that has transcended its gassy nature, a discovery that challenges our very definition of the group. Not only is it likely a solid, but it may not even be all that noble. Our 52nd fact takes us back to the surprising chemistry of xenon. The same relativistic effects that make Oganesson a solid are also predicted to make its outer electrons more reactive. It is so large and its electron shell so smeared out that it might be able to form compounds much more readily than xenon. It might be a reactive noble solid, a true paradox at the end of the periodic table.
It shows us that our neat and tidy categories are human inventions, and that the universe, in its infinite complexity, is always ready to surprise us. The existence of Oganesson is incredibly fleeting. Its nucleus is under immense strain from the repulsive forces of its 118 protons. It cannot hold itself for long. Our 53rd fact speaks to this ultimate instability. The known isotopes of Oganesson have a half-life of less than a millisecond. The atoms that were created in the laboratory existed for a fraction of a blink of an eye, before they decayed into lighter elements. It is a flicker of existence, a momentary testament to what is possible before it dissolves back into the flow of energy and matter. It exists just long enough to be measured, to prove it was there, a ghost at the feast of the elements. But the story of Oganesson is also a story of hope, a signpost pointing toward an unknown horizon.
For decades, nuclear physicists have theorized about something called the Island of Stability. This is our 54th fact, a beautiful and poetic concept from the world of nuclear science. The theory predicts that as we create heavier and heavier elements, we might eventually reach certain combinations of protons and neutrons, so-called magic numbers, that would create exceptionally stable nuclei. These elements would not decay in milliseconds, but could last for minutes, days, or even millions of years. This island would be a land of new, stable, super-heavy matter, with properties unlike anything we have ever known. The discovery of elements like Oganesson are like voyages that take us closer to the shores of this mythical island. We are not there yet, but these fleeting discoveries are like sightings of land in the distance, encouraging us to push the boundaries of knowledge ever further. Oganesson represents the completion of a journey, filling the 7th period of the periodic table, but it also represents a new beginning, the start of the 8th period, and the ongoing human quest to understand the fundamental building blocks of our reality, a quest filled with wonder, mystery, and a deep appreciation for the serene and beautiful order of the cosmos. And so, our long, quiet journey comes to a gentle close. We have drifted through the entire family of the noble gases, from the very beginning of time to the furthest frontiers of science. We began with helium, the first breath of the cosmos, the light of the sun, an element that lifts us up and allows us to see into the very heart of our own bodies. We saw the warm, dreamy glow of neon, the new one, painting our cities with its crimson light, a steady and comforting beacon in the misty night. We felt the presence of Argon, the lazy one, the invisible shield in the very air we breathe, protecting our light, our history, and our homes with its quiet, steadfast inertness. We witnessed the sudden, brilliant flash of Krypton, the hidden one, a clean white light that cuts through the fog to guide us safely home, the cosmic ruler that wants to find our measure of the world. We met Xenon, the stranger, with its futuristic blue glow, the gentle force that pushes our spacecraft to new worlds, the surprising element that showed us even the noblest among us can form a connection. We listened for Radon, the fading echo, a whisper from the deep earth, a fleeting presence that reminds us of the planet's slow, geologic time and the constant, graceful dance of transformation. And finally, we glimpsed Oganesson, the unseen horizon, a flicker of human creation at the very edge of possibility, a noble solid that completes our understanding of matter, while pointing the way toward new mysteries yet to be solved. Each of these elements, in its own way, embodies a kind of peace. They are the calm, contemplative members of the cosmic family. Their electron shells are full. They are complete. They have little need to react with the turbulent world around them. They are content to simply be. And in their serene, self-contained nature, we can find a beautiful metaphor for the state we seek now at the end of this day. As you settle into your final, deep moments of relaxation, let this be your guide. Let your thoughts, your worries, the reactions of your day simply cease. There is no need to bond with them, no need to engage. Allow them to drift by, like a lone helium atom floating into the vastness of space. Feel a sense of completeness, just as you are. You need nothing else. You are whole.
Embrace the noble stillness within you. Let it be a protective shield, like Argon, keeping you safe and calm. Let it be a gentle, steady light, like neon, warm and unwavering in your inner world. Let this peace be a guiding light, like Krypton, showing you the clear, simple path to rest. Allow this quiet to be a gentle push, like Xenon's ion drive, moving you silently and effortlessly into a state of deep, restorative sleep. Breathe in slowly and deeply, and as you breathe out, let everything go. Just as these elements rarely react, you too can choose to be at peace. The universe is filled with magnificent, silent wonders, and tonight you are one of them, resting, calm, complete, drifting now into a deep and peaceful sleep. Sleep well, friend. Sleep well.
We felt the presence of Argon, the lazy one, the invisible shield in the very air we breathe, protecting our light, our history, and our homes with its quiet, steadfast inertness. We witnessed the sudden, brilliant flash of Krypton, the hidden one, a clean white light that cuts through the fog to guide us safely home, the cosmic ruler that once defined our measure of the world. We met Xenon, the stranger, with its futuristic blue glow, the gentle force that pushes our spacecraft to new worlds, the surprising element that showed us even the noblest among us can form a connection. We listened for Radon, the fading echo, a whisper from the deep earth, a fleeting presence that reminds us of the planet's slow geologic time and the constant, graceful dance of transformation. And finally, we glimpsed Oganesson, the unseen horizon, a flicker of human creation at the very edge of possibility, a noble solid that completes our understanding of matter, while pointing the way toward new mysteries yet to be solved. Each of these elements, in its own way, embodies a kind of peace. They are the calm, contemplative members of the cosmic family. Their electron shells are full. They are complete. They have little need to react with the turbulent world around them. They are content to simply be. And in their serene, self-contained nature, we can find a beautiful metaphor for the state we seek now, at the end of this day. As you settle into your final, deep moments of relaxation, let this be your guide. Let your thoughts, your worries, the reactions of your day simply cease. There is no need to bond with them, no need to engage. Allow them to drift by, like a lone helium atom floating into the vastness of space. Feel a sense of completeness, just as you are. You need nothing else. You are whole. Embrace the noble stillness within you. Let it be a protective shield, like Argon, keeping you safe and calm. Let it be a gentle, steady light, like neon, warm and unwavering in your inner world. Let this peace be a guiding light, like Krypton, showing you the clear, simple path to rest. Allow this quiet to be a gentle push, like Xenon's ion drive, moving you silently and effortlessly into a state of deep, restorative sleep. Breathe in, slowly and deeply, and as you breathe out, let everything go. Just as these elements rarely react, you too can choose to be at peace. The universe is filled with magnificent, silent wonders, and tonight you are one of them, resting, calm, complete, drifting now into a deep and peaceful sleep. Sleep well, friend. Sleep well.